Hi everyone. Good morning guys. How are you? Guys, confirm once whether am I audible to you or not? Guys, confirm once. Show the center connected. Shillong, am I audible and visible to you? Okay. So how are you, Shillong? You guys there? Shillong. Guys. Okay. So in the last class, we were discussing about the Dalton's atomic law. I hope so it is clear to everyone. Okay. So let's start with a question. I'm giving you a question. You have to solve that question. After that, we'll continue with the next topic. Okay. Please solve the question. I hope so. Everyone is great. They are feeling good. All are healthy. All are active, energetic. Okay. With this hope, let's start with today's session. Okay. And I need answer for this question. See, equal weights of helium, CH4 and O2 are mixed in a container at 25 degrees Celsius. Calculate fraction of total pressure exerted by helium. Attempt this question, guys, and tell me the answer. What could be the possible answer for this one? Don't talk, guys. Do this question. Stop talking. Kindly confirm once after attempting the question. Done, guys? Okay, what's the answer? Okay, you have done the question, but you haven't got the answer. Isn't it? Is it like this? Look at this. 0.48. Oh, okay. 0.8. Let me check. Helium, CH4 and O2. Okay. Now we have to calculate the ratio of their pressures, and we know that the ratio of the pressure is equals to ratio of the number of moles. So number of moles will be what? W, which is given weight, upon 4 is to W upon 16 is to W upon 32. This is the mole ratio, and this is also the ratio of their pressures as well. So W will get cancelled out, and we can't left in the form of fractions, so I'll convert this into the whole numbers. For that, I'll multiply with the biggest number, which is 32. Right now I have got 1 as 1 by 4, 1 by 16 and 1 by 32. So I'll multiply all of these with 1 by 32. So to get a whole number ratio. So this is 8, this is 2 and this is 1. We have to calculate fraction for the helium. So this is what? 8 upon total. 8 plus 2, 10 plus 1, 11. So this is the answer. Pressure fraction for helium. Are you getting this? Confused? Reply quickly. If you got confused or you haven't get this, please let me know. I'll explain it in some other manner as well, so that it will be clear to you. Can I proceed if it is clear to you? See guys, your net speed is not too good, so I cannot see your actions in the camera. So you need to use your system. Okay. Oh, hi Itanaga. Did you remember that in the last class we have done one question? And first of all, I have told you, hi, good morning. First of all, I have told you to remember this relation. P1 upon P2 is equals to I'm repeating, dear. I'm repeating. Just look at the screen. P1 upon P2 is equals to what? N1 upon N2 is equals to mole fraction of 1 upon mole fraction of 2. I have already discussed with you. Okay. See, I can write it like this as well. P1 is to P2 is equals to what? N1 is to N2 is equals to what? X1 is to X2. Okay. If I say I have got one more pressure over there, so I'll put in the ratio here, I'll put its mole here, and I'll put its mole fraction here. Okay. I can have many gases, doesn't matter, 2, 4, 10, 12, doesn't matter. You can simply put all these gases in this manner. That's it. And you have to use this one. If you have two gases, you can use for the two particles, or we can say the two substances. If you have got the three gases, you can use like this for the three gases. If you have four, you can put the four over there. Okay, and so on. Now, in the last class, look at this. In the last class, I don't remember the gases, but let's consider we have got CH4 and O2. Let's consider this one. Okay. Weights are equal, which is given to us. Weights are actually equal. Okay. And we have to calculate the pressure fraction for CH4. Let's suppose we have to calculate the fraction of the pressure exerted by CH4. This is our question. When equal weights are given to us. Now, what can I say? That the pressure of CH4 with ratio of pressure of O2 should be equal to what? Moles of CH4 is to moles of O2. Okay. What can I do? That moles are nothing but what? Given weight upon molecular weight. So given weight is W, which is not given to us, so I have considered it as a W, and molecular weight is 16, is to 16 upon 32. Just solve this. Just solve this. Look at this. On solving, you will get 1 is to 1 by 2. I hope so it is clear to everyone that you can solve this one. Okay. So this is, look at this. This is the ratio of pressure of CH4 and O2, which is 1 is to 1 by 2. Guys, the point is, do not left the fractions like this. Okay. Try to convert them into the whole numbers. To convert into the whole number, what I have to do? I have to pick a number, the smallest number that can make it a whole number. So that smallest number most of the time would be the number which is highest in the denominator part. So I can multiply with the 2 and here with 2. See, you have to multiply with the common number, so you will get 2 is to 1. We have got the ratios. P1 is to P2. Now, calculate the fraction. Let's suppose we are calculating for the CH4. What we have to do? Moles upon total moles. Or we can say the pressure upon total pressure. Okay. This is how we can calculate the pressure fraction for the two gases. Now, let's say suppose we have got the three gases, like in the previous question. Look at this. I have just calculated P1 is to P2 is to P3. And after that, I have to calculate for this one. So I have put this value at the numerator part, and in the denominator part, the sum of all these values. 8 plus 2 plus 1, which is 11. Now clear? Now clear? Will you say something? Okay. You can copy this one. Copy this one. This can help you. See, in the exam, obviously the student who solves the maximum question will have the maximum chance of getting the selection. But yes, the students who has got maximum correct question with the minimum time will have much more, we can say, the chances to get a college, or we can say to get clarification in the exams. Okay, so guys, these are the tricks. Okay, yeah, these are the logical ones. I have discussed the logic as well with you. Okay, so this is just for save the time. A student who can solve this question with in a 1 minute, or we can say 1.5 minutes. If you understand this one, I can assure you that I'm sure you can do this question within 30 to 40 seconds. Okay, so in every question, if you save these seconds, 20 seconds or 25 seconds or the 10 seconds, okay, that can give you extra 10 to 15 minutes. Okay, that will help you in the difficult questions. Now, that's all about your Dalton's law. That's over. Okay, now let's move on to the next topic, which is diffusion. I hope so everyone has heard about the word diffusion. Let me give quick introduction regarding the diffusion. If I talk about the basic definition that we have learned in the lower classes, like 8th, 9th or 10th, that diffusion is nothing but intermixing of particles on its own. Means without any external help, the intermixing of particles is known as what? Diffusion. I'm sure you have already read a statement which says that diffusion is what? Movement of particles from higher concentration to the lower concentration. First of all, guys, make it clear that this statement is valid only for the liquids, the statement which is you are using. Okay, I mean to say that this is valid to only those substances which have the ability to flow. Okay, I'm generalizing the statement. I'm just saying it is the intermixing of particle on its own without any external help. Okay, let me take an example. Let's suppose we have got water. I have put a KMnO4 into it. So what will happen? The whole solution will become colored. It will become purple. Okay, so we haven't did anything. That spreading of color is happening on its own. Okay, we are not making any efforts while doing this. Okay, so this is our diffusion. Okay, let's say suppose fragrance. Let's talk about the fragrance. Okay, let's suppose you use a deo or perfume. Okay, it spreads in your surrounding. If I spray a deo, or we can say room freshener, in the one corner of the room, the smell, or we can say the fragrance, move in the whole room without your efforts. This is again what? A diffusion. Okay, so guys, diffusion has many examples available to us. Let's say suppose let's talk about the diffusion of the solids, diffusion in the solids. What to do? Use a chalk stick and write something on the board using chalk. Okay, and leave that for let's suppose 10 to 15 days. What will happen? That the particles of the chalk will get diffused into the solid surface of the board, and it is very difficult to rub. Okay, so that difficulty while rubbing those words that we have written represents that the particles which were present on the surface of the board were actually get interacted with the solid surface of the board, and they get diffused with each other. That's why now it is difficult to remove. Okay, so this is the example of diffusion in solids. Okay, we have many, or we can say many millions of examples available to us of the diffusion in solids, liquids and the gases. Okay, here the chapter we have to cover the gases only. So I'll talk about the statement which is applicable to the diffusion of gases only. Okay, I hope so you have clear with the meaning of word diffusion. Okay, so guys, first of all, let's write its definition, then we will continue. Okay, so we can say tendency of a gas to move from high pressure to low pressure. Remember guys, this statement is applicable to gases only. Okay? I'll write the general definition as well. Until its partial pressure becomes equal in both sides. Is known as diffusion. Okay. Let's take an example. Look at this. We have got N2. This is bulb A, this is bulb B. Pressure is 5 atm. This is O2. Pressure is 10 atm. Okay. Now, stopcock is open. We have removed that stopcock. So obviously, right now the situation is that both the gases are present in a particular room, or we can say particular space. Okay, like N2 is present on the left hand side only, which is A side, and O2 is present on the right hand side only, which is the B side. Now, whenever you will remove the stopcock, what will happen? That N2 will start moving towards the B, whereas O2 will start moving towards the A. And let's see that what will happen finally when we will do this. Look at this. See, pressure of N2, pressure of O2, pressure of O2. The statement says that the pressure should become equal in both the sides. Okay, so pressure of N2 on left hand side will become 2.5 atm. On right hand side it will be 2.5 atm, which is equal. Whereas if we talk about the O2, this one will be 5 atm, and here this one will also get what? 5 atm. Okay, so when this condition reached, so we will say that the gases now can't diffuse furthermore. Okay, see, on the left hand side you have got 7.5 atm of pressure, and on the right hand side as well you have got the 7.5 atm of the pressure. Okay, this is a generalized statement for the diffusion of gases. Okay, copy please. And please confirm, is it clear to everyone? Is it clear to everyone, this generalized statement? Copy. Okay. General definition of diffusion, which is applicable to everyone as in solid, liquid and gas. It is your intermixing of particles on its own, known as diffusion. It occurs in solids, liquids, and gas. But in case of gas, rate is highest. Means it is the fastest process that we can observe while we talk about the diffusion in gases. Okay? Because particles are very free to move. Okay? Particles are very free to move. Copied? Now, effusion. Can anyone please tell me what is the meaning of effusion? What do you understand by the term effusion? Or this is the first time that you have seen this word? Okay, let me. Outward diffusion. Okay, and what is inward diffusion? Outward diffusion is effusion, and inward diffusion should be what? Okay, let me tell you. See, I'm telling you the two scenarios. See. Here we have got O2 gas. Okay. Right side is blank. Blank as in that is vacuum. Nothing is there. Wow. बहुत महान हैं आप. Congratulations. Look at this. Again O2 and right side is open. Now, this red line is a separator. Means if I place this one, the gas won't move. The gas won't move from left side to the right side. If I place this separator, okay. What I have did that I have made a hole like this. This is the hole. So obviously, now gas can start moving from left side to the right side, okay, which is diffusion, okay. Now, what I have said, I made a pinhole, okay. This is what? Pinhole. Obviously, through this pinhole as well, the gas will diffuse. In both the cases, diffusion taking place. But the difference is, I mean to say that in both the cases, movement of particle is taking place. But the difference is, in the one case, the area from which gas is moving, or we can say the passing, is very large, whereas the second case where is area from which gas is moving is very small, which is a pinhole. So where the passing area is very small is known as the effusion. We can say that the movement of the particles through a pinhole is known as nothing but what? Effusion. So the case number 2 is actually represents the effusion. Okay. Now let me take another example. Let's say suppose you have got a bike, okay, and this is just you have to suppose, okay, don't take it personally. Let's say suppose your tire get burst, okay, what will happen? That if you look at the tube, don't say sir tubeless tire are there, okay, I'm talking about the time where tubeless tire were not present, okay. So if tube get burst, what will happen? That the area from which the gas was releasing was very high, okay, whereas if you put a pinhole in the tube, what will you observe? The gas will release very slowly from the tube, okay. So in the one case we can observe the two phenomena. If tire get burst, you will say it was diffusion, whereas if you make a pinhole and gas releases very slowly through that pinhole, you will say it was the effusion, okay. So this is how diffusion and effusion are different from each other. In both the cases, particle, or we can say the gas, will move from higher pressure to the lower pressure, but the path from which it is moving will be different. That's the only difference over there. Are you clear with the effusion, guys? Are you clear with the effusion? Confirm once. Okay, very good. You can copy this. I'm writing its definition. Movement of gas. Itanagar, is it clear to you? Confirm once. From high pressure to low pressure, from a pinhole. Area. This is very small area. Copy please. I can see the students who are talking to each other. So guys, will you please stop talking? Copied? Okay, let's move on. And again, guys, now there was a scientist who gave his law while movement or for the movement of the gas particles. Okay, I'm trying to relate it with the general life. First of all, don't take it personally. Okay, this is not applicable to everyone. Okay, but just think about it. Graham's law of diffusion. Look at the screen and tell me. See, there are two persons. One second. Let me draw the person. Oh, this is really bad. One second. Look at this. This is person A. Okay. This is person B. The weight of person A is 200 kgs. See, don't take it personally, okay? This is generalized only, okay? I'm not saying this is true, but yeah, you can relate. And there is another person whose weight is 40 kg, or let's say suppose 60 kg. Okay, both have the same age group. Okay, both are, let's say suppose 30 years old. Tell me, which person can run faster? Person A or person B? Which person can move faster? A or B? Okay, very good. So that's what's said by the grams. It simply said that the heavier gas will move slowly, whereas the lighter gas will move faster. That's what the stated by the grams. Okay. So ultimately, we have to learn a few formulas here, and these formulas ultimately saying this statement. Now look at this. Let's talk about the case 1, where pressure is constant. Okay, it states that rate of diffusion of any gas is inversely proportional to square root of molar mass, which we can say density or vapor density. Under similar condition of pressure and temperature. As well as area. Okay. So it simply says that rate is inversely proportional to molar mass. Okay, this is the first statement. Okay. If I talk about the general formula, that formula actually this one is rate is inversely proportional to pressure into area under the root temperature and molar mass. Okay, copy. R is rate. R is rate. M is molar mass. P is pressure. A is area. is temperature. Okay, 1 second. First of all, copy this one, then I'll show that the previous slide. Guys, mark your attendance, please. Shillong Itanagar. Okay. Copy. Okay. Guys, by the tomorrow we'll wind up this chapter, and after that we will start with the equilibrium. Next, one of the most important chapter where you will get about 3 to 4 questions in your examination. Copy and confirm. Itanagar. Okay, slide up. This one. Okay. This one. Over now? Okay, let's move on. Guys, look at the screen. Now, for 2 gases. Let's say suppose we have got gas 1 whose rate of diffusion is R1 and it would be proportional to the under the root M1. Another gas which is proportional to the under the root M2. Obviously, if I remove the proportionality sign, I'll have a proportionality constant that will get cancelled out if I divide these two. So look at this. I have divided R1 with R2. So what will I get? Under the root M2 upon under the root M1. And this can be written like this. Under the root M2 upon under the root M1. Very useful formula. Copy. Okay. This is a question for you guys. Calculate ratio of rate of diffusion of helium to CH4. I want this solution along with your name. Quickly. Tell me the answer. Tell me the answer quickly. Okay, very good, Paul. Paul has got the answer. Andy has got the answer. Balajid. And what about other students? Are they doing time pass in the class? Or they are waiting for me? That the person in front of us will get. Okay, and everyone is, oh wow, very good. Nice. Very good. What about you, Itanaga? Have you done that? You guys are superstar. Look at this. Let me check it. So what's the answer, Itanaga? R1 upon R2. I can say, in spite of R1, this is R of the helium to the R of CH4 should be equals to what? Under the root molar mass of CH4 upon molar mass of helium. So molar mass of CH4 is 16, helium is 4. So when you will solve it, this one will be what? 4 upon 1. So on solving, you will get the 2 upon 1, which is 2:1. Okay? Very good. Now let's check out the next question. Do this question. Rate of diffusion of an unknown gas is 1.73 times smaller than oxygen. Calculate molar mass of unknown gas. Tell me this time, what could be the answer for this one? Tell me the answer. Very serious discussion going the what I was saying. Leave it. Solve this question. I forgot what I was saying. $47.8. Who got this answer? Okay. Balajit, Formwell. What about others? What do you get? What about you guys? Should I start? If you have attempted. What about you guys? Nitish, Nefi, Amika, Priyanka. What are you doing? Are you waiting for the breakfast? Okay, 3.2. Wow. Annie has got 3.2. Let me solve this. What about you, Itanaga? Dear, have you solved that question? And what's your name at the Itanaga Center, student? Please share your name. Guys, this question was very simple. The question is saying rate of diffusion of an unknown gas is 1.73 times smaller than oxygen. It is saying that R1 upon R of O2 is 1 upon 1.73. This was given to us. Smaller means it should be in the denominator part. Now, I know that I can write it like this. Molar mass of O2 upon molar mass of gas. Now, look at this. I think so this is root 3. Molar mass of O2 is 32 upon M1. Do you know, guys, what is the value of root 3? It is 1.73. Value of root 3. So, roots will get cancelled out. Means you can make square both the sides. On making square both the sides, you will get 1 by 3 is equals to what? 32 upon M1. So, M1 will comes out to be 96 gram per mole. This is the answer. Clear? Guys, are you clear with this one? And one more thing, guys, every time you will get a new question, okay, so don't get panic if you are not getting the much correct answers in the first attempt, okay. The ultimate aim is to learn all these questions and all these concepts. Once you have gone through with all these questions, next time I'm sure you will definitely get it, okay. You will be able to solve in the examination. Okay, Itanagar, I'll do that. See, in the question it was saying that rate of diffusion of an unknown gas, which I have taken R1, okay, is 1.73 times smaller than oxygen, okay. Smaller means that the ratio of R1 and ratio of O2 is actually 1 upon 1.73. And we know that the ratio of rates can be written like this in the form of the molar masses, okay. Now 1.73 is nothing but root 3. I know you know the, I'm sure you know the value of root 3, which is equals to 1.732, okay. So I have put at the place of 1.73 root 3, and I have just solved this. Make square both the sides. On making the square both the sides, square gets cancelled out, and you will get 1 by 3 is equals to 32 upon m1. Just cross multiply it and you will get your answer. Now get it? Okay. Okay. Guys, you need a break or we can continue? Okay. Let's take a break of 5 minutes, guys. Remember, at the 5 minutes, 1 second, I'll start the class. Okay, so don't be late. See you in the 5 minutes. Hi guys, welcome back. Are you there? Confirm once. Okay. Hi. So guys, let's start again. I'm giving you a question and this time I hope so I'll get an answer from everyone. Okay, let's see whose name will be first on the screen. Do this question. Calculate ratio of rate of diffusion of helium CH4 to O2. Do this one. Is Nefi present in the class? Are you solving the questions? Tell me the answer. What will be the answer? What happened, Balajit? I haven't got the answer yet. Quickly. Paul. Is Nitish there in the class? Even I haven't seen his name on the screen for a long time. Two is to one. Dear, there are three gases. So you have calculated only for two. You have to calculate the ratio of rate of reactions for helium is to CH4 is to O2. Like I have discussed with pressure fraction. Okay. Who has got this answer? Any, and I think it's wrong. Okay. What about others? What do you think, guys? See, look at the formula, what formula was saying. Two root 2 is to 1 by Paul. Okay. Okay. Any other? Guys, you can solve the root, na? Solve the root. Oh, hi Lima. It's been a long time. 1 is to 2 is to 1. Okay, I have got 3 answers by 3 students. All of you have given the different answers. Now I need one more answer so that I'll get at least 4 options over there for the particular question. What about you, Itanagar? What's your answer? Two is to 1 is to 2 by Kane and Balajit. Okay. I have got 4. Okay, let me do this question. See, ratio of rate of helium to CH4 to O2 should be equals to 1 upon under the root molar mass of helium is to 1 upon molar mass of CH4 is to 1 upon molar mass of O2. In spite of writing 1, you can simply put the K, because we know that the rate is inversely proportional to the 1 upon under root of the mass. Okay, so we have removed that proportionality and we have put a constant over there. Okay, now solve this. K will get cancelled out. This 1 upon 4 is to 1 upon 16 is to 1 upon 32. Okay, so what can we do? We can solve this one. I'll get 1 by 2, 1 by 4 upon 1 upon 4 root 2. 1 upon 4 root 2. So I have told you that do not leave these type of questions in the fractions. Solve this fraction. So pick the biggest number and multiply with the every fraction over there. Biggest number means the numbers which is given to us, which are available to us in the ratios, and I think so, which is 4 root 2. So multiply with the 4 root 2 into 1 by 2 is to 4 root 2 into 1 by 4 is to 4 root 2 into 1 upon 4 root 2. Okay, so on solving this, I'll get 2 root 2 is to root 2 is to 1. Okay, so in the options you might get a root. Okay, if roots are not given to you, you can solve. Means make square of everyone. So 2 root 2 square root 2 square into 1 square. So what will you get? 2 to the 4 to the 8 is to 2 is to 1. So you can have two answers. You can have 8 is to 2 is to 1 and 2 root 2 is to root 2 is to 1. These two are the possible answers. First of all, confirm guys, is it clear to everyone? Is it clear to everyone? Please confirm. Okay. Remember guys, you are free to do mistakes in the class, okay, before the examinations. Okay, but remember, remove all your mistakes, strong all your concepts before the examinations. Okay, here you will get a chance to correct them, but in the examinations you won't get any chance to correct them. Okay, so remember, this is the time for the preparation. I'm giving you one more question. This time I need answers from everyone and correct answers. Guys, you're doing the same mistake. I have already discussed in the topic while when I was discussing about the fractions of the pressure. I have taken the 3 gases over there as well. And the exactly same concept is being used over here. Okay. So guys, make sure that this time you won't make any mistake. I hope so if you have got these 2 questions. I'm giving you the last question. Please give me the right answer. Okay. You have to calculate the ratio of the rates. I'm not writing the whole question. I'm just giving you the guesses. Okay, just solve this. This is your CO2, O2 and H2. Calculate the ratio of rate of reactions, CO2, O2 and H2. And Nafi, will you please stop talking and will you focus on the question? Itanagar, have you done that? Guys, in the current question, if you got any difficulty, I'll suggest solve the root first. Make the square of everyone. You will get answer much more easily. Four is to 11 is to 44. Okay. Who has got this answer? Ernie. Okay. Itanaga, are you there? Have you got the answer? And what about others? What are you doing, guys? See guys, whenever you will have a next test, I'll give you the states of matter in the test. Remember this one. One is to 11 by 8 is to 20. Today I have told you that do not leave such question in the fractions. Remove the fraction. Okay, I'm giving you the last 2 minutes, guys, for everyone. After 2 minutes, I'll solve it. Nisha, what are you doing? Have you got the answer? Okay. What about you, Balajit? Paul? Amika, Nefi, guys? Anyone there who has got the answer? Last minute. $1.375. Guys, first of all, remember one thing first of all, guys, one thing you have to remember. In the questions of the fractions or the ratios, in the 90% cases, you won't get any decimal. In the 90% cases, you won't get any decimal, as well as you won't get any fraction over there in the options. Okay? So please keep in mind. So let's start with this one, guys. This was exactly same that I have discussed previously, that R of CO2 is to R of O2 is to R of H2 should be what? K upon under the root molar mass of CO2 is to K upon molar mass of O2 is to K upon molar mass of H2. Guys, first of all, confirm me. Are you getting this, how I'm writing these ratios? This is quite a mathematical term over there. If it is not clear to you, please let me know. Are you getting this, why I am writing like this? I hope so you don't have any confusion regarding this one. Okay, that's fine. So just put the values, guys, and you will get your answer. Okay, just put the values and you will get your answer. See? 1 upon under the root 44 is to 1 upon under the root 32 is to 1 upon under the root 2. Okay. First of all, try to solve the root. Or the best thing, you can just make the square root of everyone. Just make the square root of everyone. Okay. If you can't, then you have to solve like this. This is your 2 root 11 upon 4 root 2 is to root 2. See, these are the fractions. I'm not getting a question, dear. Okay, putting the values. I was just putting the molar masses. See, molar mass of CO2 is 44 and molar mass of O2 is 32 and molar mass of hydrogen is 2. I was just putting the molar mass and solving this. Okay. So guys, I have to convert this into the normal whole numbers, or we can say I have to remove these fractions. So what can I do? How can I remove this one? So this time what can I do? I'll multiply with 2 root 11 and 4 root 2 with both. Sorry, 2 root 11. This is 2 root 11 into 4 root 2 upon 4 root 2, and this is your 2 root 11 into 4 root 2 upon root 2. See, this is got cancelled out, this got cancelled out, this got cancelled out. And what will we get? We'll get 4 root 2 is 2, 2 root 11 is 2, 4 2s are 8, 8 root 11. This is one of the answers, guys. This is one of the answers, okay? Or squaring. If you make a square of all these species, means all these numbers, what will we get? 32 is to 44 is to 64 into 11. 704. It depends in the option what is given to you. The chances, if question is normal or easier, you will get these as an option. Clear? Guys, confirm once. Are you clear with this one? Everyone? Guys, you have to use your chat screen because net speed is not too good, so I cannot see your actions. Okay, that's fine. Itanagar, now is it clear to you? Okay, fine. Let's move on. Please copy this quickly, then we'll move on. See, guys, please don't panic if you're not getting the correct answers in the first attempt. Don't panic, okay? But remember one thing, that after solving or getting the solution of every question, next time if you face such kind of question, you should be able to solve that. Okay? If you are able to do that, it means we are learning. Okay? Now, let's move on. Next topic is determination of rate of diffusion. See, case 1, volume diffused per unit time. Guys, these are the formulas. I hope so you have knowledge about the rate. Okay, rate is something, or we can say it is the change with respect to the time, change of anything, change of concentration, change of volume, change of moles, change of distance with respect to the time is always determines the rate. Okay, so I can say here rate is what? Volume diffused upon. Guys, whenever you find any difficulty regarding any word or the concept, you can please ask me at that time. Okay, upon time taken. So what can we say? That R is V by T. Now, I have to just use it. First of all, copy this one. Copy this quickly. Copied. Look at this. R1 upon R2 can be written like this. V1 upon T1 into T2 upon V2. And we know that this is equals to what? Nothing but under the root M2 upon M1. So ultimately, we have got the two new terms in spite of rates. In the previous questions, we were determining the rates. In the next questions, we might have to determine the time or the volume. Okay, so this is the formula. Copy. Number 2, distance traveled per unit time. See, R would be d by t if I talk about the rate. So if I write the same formula, so what can I say? That R1 upon R2 should be equals to what? D1 upon T1 into T2 upon D2 should be equals to M2 upon M1. Copy. Guys, are you getting all these formulas? Or you're just copying that? That a person in front of us is saying something, he will complete his lecture and he will get back to his place and we will get back to our place. Then all over. Guys, are you getting all these questions? Oh, sorry, all these concepts? Oh, you're trying to write the lol. Okay. Yes, they're clear. Okay, you start with L, so I said, oh, sorry, I assumed that you're trying to say lol. Okay. Okay, let's move on. Next, number 3. Moles diffused. Per unit time. See, R would be equals to what? N by T this time. And if I use this one into the formula, I'll get N1 upon T1 into T2 upon N2 is equals to what? M2 upon M1. Guys, again I'm repeating, very simple chapter based on the formulas. I'm discussing the tricks of the formulas, shortcuts, remember them, get the answer in the seconds. And obviously then you will be a doctor. Copied? Now I'm giving you a question. And this time I need the answers. Let's start. If 20 gram of helium diffuses through a hole in 10 seconds, then calculate mass of SO2 gas diffused through same hole in 15 seconds. Do this time. Just keep yourself calm, look at the formula, find out the important information in the question, just put the values and get your answer. Mercury. Wait a minute. I need to check it. I guess so it is 1 second. It is 200.6 molar mass of mercury. 200.6. Wait a minute. Are you thinking about that you will use the molar mass of mercury here? I don't think so that you need to use that. That mercury, see this, oh, 1 second, 1 second, 1 second, 1 second. This is not mercury. Helium. Mercury is a liquid. It can't fly. It will flow. Don't use mercury, use helium. That is why mistaken E becomes G. Guys, have you done that? Or still some serious discussions going over there in the classroom regarding the question or some other things? Done? Okay, last 2 minutes. .75, Priyanka. Okay. .46 Kane. Last minute. 106 Balaji. Okay. One more option. I need one more option. Itanaka, have you got the answer? What do you think? I said one more option. You have changed your own answer. 7.5, Nisha. Okay, let me start. Guys, first of all, confirm that have you did the same? That's what I'm doing right now. Question is saying 20 gram of helium is diffused through a hole in 10 seconds. Calculate the mass of SO2 gas diffused through the same in the 15 seconds. First of all, you have to use this formula, that N1 upon T1 into T2 upon N2 should be equals to under the root M2 upon M1. N1 I'm considering, means 1 I'm considering the helium and 2 is considered as a SO2. First of all, confirm me, have you done the same? Are you using the same formula? Or you have done something unique, out of the box thinking? Because we want to change the world. Okay, very good. Badhaio, I mean, congratulations. Let's put the value. Let's talk about the helium first. Mass given to us 20 gram. Molar mass of helium is 4. Time is 10 second here. Time is 10 second here. T2 is 15 second. N2. Mass given to us. What is mass given to us? Okay, we do not have the mass, so just put the N2 here. We don't know about the mass. Put the molar mass is 64 for the SO2 and 4 for the helium. Have you done exactly same? Have you put the exactly same values? First of all, confirm me. Confirm. Okay. Solve. This is 2. This is 2. So I'll get 15 by 2 into 1 by 2 is equal to 16. If I solve it, I'll get the 4. Okay. So N2 would comes out to be 15 upon 8. Now I have to calculate the mass. So W upon molar mass, which is 64, is equals to 15 upon 8. Just cross multiply 8. W will be equals to 15 by 8 into 64. 8 8s are 64 and 15 8s are is 120 gram. Tell me guys, what is this? Why are we not getting the correct answers, guys? Just formula based questions. What's the problem? कब तक करोगे कैलकुलेशन मिस्टेक्स? कसम खा के आए हो क्या? Sir, we won't solve your questions. Is it like that? Not getting a single correct answer. Means these are not mistakes again. These are blunders. I'm telling you, these are not questions, these are the opportunities. I'm giving you the next question. Yeah, I know that you are really trying. But guys, please don't do this. Try to improve upon it. I guess so in the current chapter, in the last 9 questions, I haven't got hardly 2 correct answers. I think I have got hardly 2 correct answers in the first attempt. Okay. This question is not formula based. This time you have to use your brain. I mean, every time you are using your brain, this is a little bit a better question. Look at this. NH3 plus HCl is giving you ammonium chloride, which is white fumes. This question has already been asked in previous entrance examination, but not in the NEET. Okay. This is asked in the JEE. You guys can solve this question. Okay, I know that. And remember guys, this time pattern is getting changed of the NEET, because this time AIIMS and NEET are getting the same. So we might get the better questions as well. Look at this. This is your X, this is your Y. Guys, you can copy the question. This is point A, this is point B, and this is point C. Okay. The length of the tube is 2 meters. Okay. Point B is the midpoint. This is your midpoint. Midpoint. Now, question is, at which point white fumes will appear first? Okay. On the left hand side, we are introducing the ammonia, whereas on the right hand side we are introducing the HCl gas. Remember, exactly at the same time both the gases will enter into the vessel. Okay. Now the options given to us: A, B, C, and D. Wrong question. I am sure that you won't get this option in the exam. Just kidding. The option is can't be determined. And this is one of the dangerous options ever had. Can't be determined. One is not possible, other one is can't be determined. Quite dangerous. 2 minutes for this question. Think about it and tell me the answer. After looking at the question, you guys are little bit serious, and you are still enjoying. They are still enjoying their own company. Doesn't matter what question says. Okay. Please write your name as well. Balajit. Okay. And this question has been asked in the engineering entrance examination. Last minute, guys, for this question. You are given with the 4 choices, at least opt one. Can I start, guys? Okay, there is again option A. Guys, you can look for the rest of 3 options as well. Don't stuck at A. Buys? Okay, B. Okay, I thought you were saying buy. Okay. Oh wow, what's your name? Thank you so much. Now, first of all, guys, doesn't matter in which examination, which question has been asked. The point is that are we able to predict or understand the meaning of the question? Okay? This is one of the easiest question that ever you have got in the engineering entrance examinations. And remember, this was very logical question, and this is based on the first statement of the Graham's law. If you remember that statement, you are able to solve this question very easily. There is part 2 as well, but part 2 we need not to solve that. Okay, so we won't go to the part 2. We have to just check out our concepts. Guys, in the beginning of the Graham's law, I told you that Graham's law is simply based on a statement that heavier gas will move slower, whereas lighter gas will move faster. Okay? So if both the gases are entering into the tube at the same time, so obviously NH3, the mass of the NH3 is actually 17, whereas the mass of HCl is 36.5. Almost twice of ammonia. So obviously ammonia can travel with the faster rate as I compared with the HCl. Try to understand this, that ammonia will move almost with the twice of the rate as I compared with the HCl. Okay? If both have the same masses, guys, try to understand that if both have the same masses, it means that they both will travel the same distance in the same time. Okay? At that time, they will exactly meet at the middle point, which is the midpoint. Okay? If one gas is lighter, and which is exactly half, or we can say it is about half of the other gas. Okay? So it will travel almost twice of the distance. It is almost confirmed that ammonia will definitely cross the point B, which is midpoint. To meet at point B, their masses should be equal, but mass of ammonia is exactly half. Not exactly half, but almost half. It means that ammonia will crosses the midpoint, and after the midpoint, we have given only one option, which is C available to us. So what will happen? At point C, the both gases will combine with each other, and they will form the ammonium chloride, which is represents the white fumes. So correct answer would be C. You can simply say, because ammonia travel with faster rate with respect to HCl. First of all, tell me, are you clear with the question? Are you getting? Thank you. Okay. So guys, these kind of questions are used for the brain exercise. Okay. I hope so everyone is getting this question. Okay. If anyone has doubt, please you can ask me right now. If not, we can move on. Let's check out the another formula. See, this was the case 1, now case 2. Where pressure of both gases is different. In the first case, we were discussing that pressure of both the gases is constant. Now pressure of both gases different. Guys, you can copy along with me, because we have already discussed the formula, just we have to put the pressure, nothing else. Pressure of both gases are different. Okay. So previously I was discussing this one. Now in spite of 1, I'll put the P, because pressure is not constant, pressure is variable. Okay. So nothing but if I try to find out the ratios, I'll get the P1 upon P2 under the root M2 upon M1. This is the new formula. Just use the pressure. Simple. Copy. Remember, temperature and area are constant. Next thing, I think I have already discussed with you, but I'm just writing it. W1 upon M1 into M2 upon W2. Okay? So remember, if I use this one, I'll have about 4 new formulas. Okay? Like this. R1 upon R2. See, P1 upon P2 is equals to what? Mole fractions. Ratio of the mole fractions is equals to what? Ratio of the number of moles as well. So I can say this can be written like this as well. Means I can pick any of the value given over there. Copy. Copied. Okay, so guys, let's wind up this one. Okay. So that's all for today's session, guys. Please make sure that you will revise again this one. Okay. Just go through the questions again, try to solve them again. Okay. And I'll continue by tomorrow. Okay. So guys, till then, take care. Bye-bye. Have a good time. Stay healthy. Take care of yourself. Thank you. Bye-bye.